You make a cube in Blender, you slap it into Unreal, create a new material, and you always have a texture coordinate. Huh? How game engines handle different 3D meshes with different vertex attributes. In rendering's APIs, the vertex attributes must match the shader layout index. If a mesh doesn't have one, well, programming is not fun anymore. The shader inputs must always match the vertex attributes. In my game engine I call it VertexContract. A vertex contract is just a fixed layout of attributes. The shader must have the exact same layout. We must guarantee that the shader will always receive those attributes. But our cube has only position and normals. Going back to OpenGL, when we bind the vertex buffer for each attribute, we bind each buffer separately. If a mesh doesn't have one, well, we just bind a dummy buffer and set its stride to 0 like this. With Vulkan, the stride is specified here, used there, just to create a pipeline. This means that we must create all the combination of missing attributes. In our case we would have 16 pipelines. This is similar to what Unreal Engine does under the hood. If we wanted the OpenGL approach, we would need to create pipelines on demand, but that's too expensive and we would run into lag spikes. Unreal creates all the pipeline at startup. For each material, it will create and compile different shader permutations. It doesn't need dummy buffers at all. But nobody wants to compile thousands of shaders either. So in my game engine I made the mesh contract binder. Basically, it just maps the mesh attributes to the correct shader layout index. If our mesh doesn't have an attribute, just bind a big dummy buffer. I use around 1 million of Vector 3, which is roughly 12 megabytes of VRAM, which is nothing for my 3060 Ti. I love the fact that the shader has only one pipeline. So I have less shaders, less to compile, less bugs, I think. It's a win-win. But why Unreal needs so many shaders? Materials in Unreal need to support a wide range of conditions, features, platforms and usages that require slightly different shader code, shader quality, feature level, shading paths, shader stages and much more. The default shader will have all the attributes, while the permutations will not have some of them. Using macros before compiling it can turn on or off different attributes. If one attribute is missing, it will use a default value instead. Having too many permutations can become an issue very quickly, leading to thousands of shader permutations. If you have noticed that sometimes applying a material to a new mesh will trigger shader compilations, now you know why.